Hello, and welcome to this video in the series on water ionization. My name is Kim, and in this video, we'll be discussing how to identify acid-base conjugate pairs. Before we can fully understand how water auto-ionizes and grasp the relationship between hydrogen and hydroxide ions, we must first review how acids and bases come in pairs. Following the Bronsted-Lowry definition, an acid is a proton or hydrogen ion donor. That is, it loses the proton. The base is a proton acceptor, or it will gain a proton. An acid and a base that is only different by the presence or absence of a proton is called a conjugate acid-base pair. The movement of hydrogen ions creates conjugate pairs. Let's take a look at our example on the bottom. We have acetic acid reacting with water to form the acetate anion and a hydronium cation. We see that acetic acid and acetate only differ by a proton, and since the acetic acid is donating the proton, acetic acid is the acid and the negatively charged acetate is our conjugate base. Protonation of the acetate will reform the neutral acid. Water and the hydronium ion again only differ by a proton. Water gains a proton from acetic acid to form our positively charged hydronium ion, and therefore water is acting as our base and the hydronium ion is our conjugate acid. Again, running the reaction in reverse direction will show that the acid can lose the proton to reform water. Using the information we reviewed, let's identify some conjugate acid-base pairs in the two reactions. In A, we see that ammonia is reacting with water to form the ammonium ion and the hydroxide ion. Ammonia and ammonium only differ by a proton, and since ammonia is gaining a proton to form the ammonium ion, ammonia is our base and the ammonium ion is our conjugate acid. Water, however, is losing the proton to form the hydroxide anion. So water is acting as our acid and the hydroxide ion is our conjugate base. In B, acetic acid is reacting with nitrogen dioxide to form our acetate anion and nitrous acid, HNO2. Acetic acid is losing a proton to form the negatively charged acetate anion, so acetic acid is our acid and the acetate is our conjugate base. Nitrogen dioxide is negatively charged and is gaining a proton to form nitrous acid. Therefore, nitrogen dioxide is our base and the resulting nitrous acid is our conjugate acid. Make sure you are able to identify conjugate acid-base pairs with practice questions, as this is going to lay the foundation for understanding how water auto-ionizes in a different video.